Hello guys, welcome back. This is again another video on brute force, and today I'm going to explain to you this really cutie exercise of brute force. Right? So here's a statement. So we are given an array of integers named nums, and we are asked to find the maximum product, so that's multiplication, it's product of three items inside the array and return it. So for example, let's say we have 1, 2, 3, and 4, right? So we need the maximum of three items. So we need at least three items. Keep that in mind. So we're going to, let's say 1, 2, and 3. Let's say we multiply that. And let's say we can also multiply 1, 2, and 4. Right, so that's still three items. And then let's say that we want to multiply 1, 3, and 4. All right, so that's another way to multiply. And then what's left? We have 2, 3, and 4. All right, that's the other one. So first 1, 2, 3, then 1, 2, 4, then 1, 3, 4. Then we are finished with the one, and then we use 2, 3, 4. All right, and that's it. So as you can see, we would have four ways to multiply this. So we need to set this in pseudocode. All right. So this can be easy at first, but it's actually a little bit confusing, I would say. Not difficult, but it's confusing when implementing. So to make it easier, I want you to understand that we are definitely going to need for loops. All right, we are definitely going to use for loops, as we are first using one, and then we are going to the next item, and then to the next item, and then we stop there. And then we are going to do the same, but to the next item, and then we stop there. So as you can see, this is a clear way that we need for loops. We're going to iterate, all right? First having one. So the trick here, all right, the trick is to think the problem, all right, to think the problem with a small array as we are doing here. So don't think this with small items. First, do the most basic ones, which is going to be 4 items inside an array, all right? So we are going to implement this. First, we're going to write down the name of the function. So we're going to put max product, right? Max product. And then we're going to be needing the array itself, which is going to be nums. And for practical purposes, we're going to be given the size of the array. All right, so I need not confused there. And then as we are going to be needing the maximum product, right? We're going to set here a value named max. It could be 0 because anything will be greater than 0. But to make it more professional, we're going to put minus infinite. All right. So any 3 items product is going to be greater than this. All right. So it's just a flag, let's say, it's a variable that we need. All right. And then what we're going to do. So what we're going to do this. All right. So we know we are going to multiply 3 items, right? So let me write down here. Product, right? It's going to be item number 1. So nums, let's say 1 multiplied by nums, and that's going to be item j, and then multiply by nums, and that's going to be the third item, which is going to be in this case k. And after we multiply 3 items, what we're going to do is check if that multiplication is the maximum product. So we're going to do product. If product is greater than maximum, all right? So we know that now that maximum equals product, all right? So, but how on earth are we going to get here? We all understand at this point, right? We are going to multiply three items, and we checking if those multiplication are the maximum. That's it. But now we need to get somehow these variables, right? So first, we need to take a look at how it is distributed here. All right, so this is going to be our I, this is going to be our J, and this is going to be our K. As you can notice, K is only going to be 3 and 4, right? So with that in mind, K is only going to be 3 and 4, all right? So it's going to be basically from item, all right, from index 1, 2, 3, from index 3 to index 4, all right? So in other words, from index 3 until it ends, right? We don't know when will it end, all right? We have no idea. But what we know is that these 3, all right, this index 3 is greater than index 2. All right, so we could say that 2, we could, instead of saying index 3, we could say that it is index 2 plus 1. All right. So we can write that down. So let's write that down. 4k equals 2 plus 1, 2n. So that's what we have written here. All right. Now we don't want to express these two here, so we're going to continue analyzing the problem. So as you can notice, J is the second item, and J here in this little example, J is only going to be 2, all right? It can also be 3. So it's only going to be 2 and 3, right? As you can notice. So J is only going to be 2 and 3. So what that means? That means that J is going to start from index 2 and it's going to end to n minus 1. In other words, 3. But 3 can be expressed as n minus 1. Obviously, because this is 4, right? So this is we have an array of size 4, all right? And we are here, we have index 1, index 2, index 3, and index 4, all right? So it is saying that we need not the last item, but the item before the last one. So this one, because if we put n, we know n is 4, so we can index 4. So that's why we are, and we are resting 1, because we need the item before the last one. So that's why we can express 2 or 3. Let's say 3, we can express it as n minus 1. All right. So again, we know that J is only going to be 2 or 3, right? So we're going to express that as this will start from index 2 to index 3, and index 3 can be expressed as n minus 1. So that's why I'm going to look here, n minus 1, all right? And how can 2 be expressed as well? Well, we know that 2 can be expressed as index 1 plus 1, all right? So that's what we're going to do here. We're going to write that down. We're going to write J is going to be basically index 2 that can be expressed as 1 plus 1, all right? And it's going to be until what? Until 3, and 3 can be expressed as n minus 1. So that's what we write here. And lastly, we're going to analyze I. I can be just 1, or it can be 2 as well, as we have 2 plus 3 plus 4, all right? So as you can see, 1 can be index 1 and index 2, right? And how can you express index 1? Better say, how can you express index 2? If index 3 can be expressed n minus 1, then index 2 can be expressed as n minus 2, right? Did you get the idea? And now 1, right? 1, it can stay. We don't express that as 0 plus 1. right? But we could do it. So we're going to write that down. All right. So all right. So we're going to write that down. We're going to write another for. So basically, I, which can only be 1 or 2, starts in index 1. All right, and it only reaches 2. And how can 2 or index 2 be written as n minus 2? So that's what we write here, n minus 2. And of course, now we know that we can replace this 1 and this 2, right? Because what is 1 is I. Then we replace this 1 as I. And what is 2? We set 2 as we can send 2 as j, because this was 1 and plus was 1 is 2. So we can set this as simply as j. And that's what we have here. And then what we do, we go and return, right? We go and return the maximum. And that's the whole algorithm, all right, function. So as you can see, the analyzing this can be kind of confusing, all right, but it is actually not, because we don't start by thinking how we are going to do this for. We start simply by focusing, all right, on how this multiplication works and what number is going to be here and what number is going to be here and what number is going to be here. So it's really important that you express the example with a minimum viable amount of numbers. All right. So with that in mind, you can express things as an n. All right. That's how we end up here saying 2n and then 2n minus 1 and then 2n minus 2. It makes sense. All right. I know it can be confused, but if you didn't get the gist of it, just watch the video again and hopefully you can understand it better. So that's it, guys. Thank you very much for watching. See you next.